So hi everybody, thanks for coming. My name is John O'Reilly. I'm a software engineer at Cisco, where I've been developing Android apps for about 9 or 10 years now. Now obviously, determined that you can hear me, I've been told I speak very quickly, so wave your hands madly around if I speak too quickly, or you can hopefully watch the recording in half speed or something like that later on maybe. But I will try and slow down. So I'm going to give an overview in the next 15 minutes or so of an exploration I did recently to see how we can use SwiftUI. This is the new declarative UI framework announced by Apple this year to create an iOS app that consumes shared multi-platform code. It's quite a mouthful. So the usual sort of quick show of hands, who here has sort of dabbled with multi-platform? Tried it out at any stage? Kevin doesn't need to raise his hand, no? And how many people have sort of, are aware of SwiftUI or has some familiarity? Oh, great. And sort of clutching at straws, any iOS developers here? Anybody? Oh, wow, okay. You keep me honest. Damn. I have to change my slides now. I wanted to start by giving, setting the stage a little bit by giving a pretty brief overview really of what some pretty recent developments that have taken place this year that have made something like this feasible. Firstly, there's obviously been a very dramatic migration over to using Kotlin for Android development. Sort of galvanized this year by the Kotlin first announcement at Google I/O in May. And I think it's reasonable to say that this is sort of at least a contributing factor for the next item here, which is this year has clearly been a year of sort of increased maturity and profile of Kotlin Multiplatform. And I'm not going to go into too much detail about Kotlin Multiplatform too much so. I mean, there's a number of other talks that you might have gone to already and that are going to take place in the conference. But certainly you've seen much more posts about it, much more talks at conferences like this about it. So next up, important in the context of this discussion is the emergence, or at least announcement, of declarative UI frameworks on both Android and iOS. Firstly, we had Jetpack Compose at Google I/O in May, and then a few short weeks later, SwiftUI obviously at WWDC. Now, again, there's a number of very good Jetpack Compose talks that have taken place already, and I think maybe some others planned. So definitely would recommend watching those. So I'm obviously going to focus on SwiftUI today. This last item is a little bit fuzzier. I know folks follow Jesse Wilson from Square. You might have seen a post from him earlier on this year where he talks about, at least at Square, sort of, some degree of convergence taking place, between iOS and Android development. Swift is obviously the main language being used in iOS right now, Kotlin on Android. They're obviously very similar languages, opening up the possibility of shared code reviews, something that Jesse mentioned they were doing at Square as well. And this again is in the context of potentially bringing in Kotlin Multiplatform into a project. Now he also, by the way, and I have links in the resources, he did a very good fragmented podcast episode afterwards where he goes into this in a bit more detail. And the other thing he mentions here is that there's some alignment of vocabulary and architecture being used between iOS and Android. And I mention this here because this is one of the things that became apparent and that was kind of nicely illustrated as I was going through this exploration. So I'll talk about that a little bit more. One thing to mention, because I hadn't had this in the notes, but I went to Jeremy Rempel's talk earlier this morning. Definitely, if you haven't been to that, definitely recommend it. He touches on a lot of these items as well. So a couple of quotes that I think nicely capture what differentiates multi-platform from other approaches. The focus, as alluded to by Kevin here, is on shared logic as opposed to shared UI. The second quote is a post from Jesse Wilson from that blog post I mentioned. And he captures that key point about optional code sharing. And it's the point, it's the point that's been mentioned by Kevin many times as well. And I mentioned here is something that was really nicely illustrated again as I was going through this exploration. Sort of, it became very apparent in terms of as I was kind of gradually migrating to the shared code and starting to pull in different parts of the code base. That capability that obviously that differentiates this approach from other approaches. So just to give, first of all, some context to the example app I'm using. I have an Android app in the Play Store that shows bus route, timetable, location information for the city of Galway where I live. And it's an open source project, and I tend to use it as a platform for trying out new technologies like this. And often before I bring them in, you start using them at work. So like many people, I'd been trying out Kotlin Multiplatform. And as chance would have it, literally the day before WWDC, I got to a good milestone in terms of sort of shared Kotlin repository class being used in an iOS and an Android app, as shown here on the left. And it's important to note that the iOS UI here, was developed obviously using, at the time, the traditional, inverted commas, traditional sort of iOS development approach in terms of view controllers, storyboards, table views, etc. And it's worth, as an Android dev, who fairly infrequently fires up Xcode, always struggle to understand where the various moving parts fit together. And this is why, the next day then, when I saw the announcement of SwiftUI at WWDC, my interest was piqued, both in terms of how sort of accessible this approach to UI development was for somebody who was very novice at iOS development like myself. But it was also intrigued by the combination of this and shared multi-platform code. So I downloaded the Xcode beta, which was available straight away to download and started trying it out. So stepping back a little bit, what is SwiftUI if you haven't come across it before? It's described here by Apple as a simple way to build user interfaces for all Apple products, using the power of Swift. And that's it's an interesting point, by the way, is that this isn't just for iOS. You can use SwiftUI for Mac project applications as well. And the example here was my very first attempt at trying it out. It very basic, shows a list of bus routes. It had provided the list of routes already to it. But I think it shows, how expressive and succinct this approach to UI development can be. And what that sort of initial attempt evolved into was something closer to what's shown here. Where we start using something akin to iOS, akin to MVVM on iOS as we're doing on Android. On Android, we're using standard Android architecture components approach. We're using, single activity approach, multiple fragments, navigation components, live data view model, the whole shebang. And on iOS, we obviously have our UI in SwiftUI now, but we're using this observable object, which is something similar in function, at least the way I sort of see it, similar in function to sort of a view model on Android. And in fact, that initial version of Xcode that I downloaded has something here called the bindable object. I don't know if people have sort of looked too deeply into SwiftUI. And the bindable object was described in the documentation as a view model. But that got dropped in, I think, beta 4 of the Xcode 11 and got effectively replaced by this observable object. And this, by the way, is part of the new combined framework. There's a new reactive framework being built out on iOS right now. It looks pretty interesting. And observable object is part of that. So I kind of alluded to it. I mentioned about architectural alignment earlier. In this example, we're using MVVM. On Android, it's something looks like it a little bit on iOS. And there's nothing that a good part of the value proposition of Kotlin Multiplatform is it doesn't necessarily force you to use a particular architecture, one or the other. And there's that sort of temporal, incremental aspect of it. Starting off, you're probably going to be, or in many cases, there's going to be a different architecture on Android and iOS. And I've seen, I've seen many examples of one or the other, but certainly the more that you do align the architecture, I think the more opportunities that opens up in terms of how high up the stack you can target the shared code at. The other thing is, the example. If you do start doing that, for example, I've seen some MVP examples, and I think the talk this morning gave one as well, where you, in an MVP scenario, for example, you might have your presenter in the shared code, and that fits there quite nicely. Personally, for using an MVVM like I'm using here, I tend to like using the Android view model from the architecture components. It has a lot of nice Android-specific capabilities, things like saved instance state management, view model per navigation subgraph, data binding support, and quite importantly as well, and I'll show you later, implicit sort of view model scope for coroutines. But you could imagine that part of your view model could be implemented in the shared code, and there's some samples of that as well that I've seen. The other thing worth mentioning at the shared, so looking at the shared code, in this particular example, I've targeted the repository. I mentioned about sort of an MVP where you could have the presenter in there. And likewise, again, in that talk this morning, if you were using sort of a fully clean architecture approach, you can imagine your use case, your interactors residing there, and that would be a sort of a natural place for them to exist in shared code. The other thing, the other thing I wanted to mention was, if you look in the Android app module right now, you can see that, at least right now, we're still using retrofit to make remote API requests to a backend. And I've left that there as a sort of, it nicely highlights the optional code sharing aspect. Here's a case where, I can sort of incrementally adopt shared code into my project, and then gradually migrate the platform-specific code into the shared code base. And like I said, in the shared code as well, we're using SQLite for connecting to persisting our data into an iOS or into SQLite database on iOS or Android, and KJOR client for connecting to a backend service. So this is what the SwiftUI code evolved into. We've added, for example, more formatting. We have an app bar title. We're starting to use some SwiftUI callbacks here. And you can see certainly how expressive this approach is compared to what I mentioned earlier in terms of using view controllers and storyboards and so forth. And sort of as an aside, as I was kind of thinking through this, I'm sort of another fragmented podcast. I'm not advertising for them, but there was a very interesting one with Leland Richardson. He works at Google now on Jetpack Compose, and he made the very interesting point about the separation of formats that you get traditionally in mobile development, with a layout file, for example, on Android or storyboard on iOS. That separation of formats doesn't necessarily imply, in all cases, a separation of concerns. That there's a lot of implied coupling that goes on between those, which is obviously interesting in the context of this type of approach, where we're effectively doing our UI in one place, using with SwiftUI like here, and similarly like with Jetpack Compose. So a few things to note here. We're now sort of effectively, compared to that earlier example, we're now injecting our what I'm describing as a view model using this environment object notation. We now trigger retrieval of the data in the onAppear callback in the SwiftUI code. So we're calling into the view model fetch method. And any updates to our list then are automatically cause the UI to update accordingly. If you can see sort of the list element sort of under the navigation view, that's referring to the bus routes model, view model, list routes. And I'll show an example, sort of the mechanism behind that. And obviously the UI then on the right is what's generated from that SwiftUI code. So the top left is the sum total of the view model right now. I mentioned earlier versions were using something called a bindable object, and that's actually quite a lot more verbose than this. Here we have something called this at published, our list routes. Again, I'm kind of conceptualizing this as very similar to live data in an Android view model, for example, an observable piece of data. And this is what we were, if I go back a slide, this is in our SwiftUI code under list. We're effectively observing the bus routes view model dot list routes, and that's what this at published element effectively represents. And in the onAppear in our SwiftUI code, we call the fetch method here. And this Swift code at this point here, we're calling into the Kotlin repository class to fetch the list of routes. And when that data is returned, we set it against list routes. That updates the UI accordingly. And you get this sort of observability aspect of it that you'd be probably familiar with in terms of using things like Android view model and live data. In the Kotlin repository, this is our fetch bus routes. We have sort of two overloaded methods right now. We have the first one is what's right now is called from the Android code. It's a suspend function, and in fact it's called from a view model using that view model scope that I mentioned earlier. The second method is the one we're calling effectively from iOS. We're passing in a lambda in here, and we're calling into the other method. I have a kind of in my own sort of to-do list in terms of this exploration. Trying to get a better feel for really how, and I think it's a general question, I suppose, how coroutines fit into this kind of environment. And again, it depends on, we talked about how high up the stack you go in terms of what your layer of abstraction is that's exposed from there, what creates that initial view model scope and so forth. So I think that's kind of a TBD. I think it's something that's going to evolve in this space as people understand it better. So it's worth mentioning that there's a number of plugins that make use of Kotlin in Xcode much easier. There's a CocoaPods plugin that basically allow you to set things up so that effectively when you make a change to your Kotlin code in Xcode, it'll automatically build the multi-platform Gradle module for you and do that seamlessly for you. There's also two plugins from Touch Labs. One allows you to sync your Kotlin code into your Xcode project, and the other one allows you to debug your Kotlin code within Xcode. So as I was doing this, sort of when I looked at this particular code, I thought I might add one more slide. So when I was looking at this, that create DB, just an opportunity to mention. Again, other talks have talked about this before. This is sort of expect an actual implementation or mechanism in multi-platform. here we have a create DB method, which is going to create my database. If you see at the top of the code here, and I'm calling that in my shared code, expecting something to implement that. This is kind of almost like override mechanism that you have in multi-platform. And these are the actual implementations then. Within your multi-platform module, you typically will have Android-specific and iOS-specific code. So my Android-specific code, this is my implementation of CreateDB. In my iOS code, this is my implementation. They will be in different source trees. And that's obviously a critical aspect of multi-platform, that you can do that you can effectively override and provide platform-specific implementations for these things. This is resources which I will certainly share the slides probably over Twitter afterwards. So don't, obviously, and thank you very much. Actually, just to mention as well, sorry, there's a GitHub, there's a repo here as well. Any of the source code that I showed in the slides or in general that I did as part of this is in that. It's an open source repo that you can look at. Thank you very much.